This is Team 38, and we're presenting our project, which is facial age detection using artificial intelligence. Whenever we see someone new, it doesn't take long for us to guess their age. However, when we guess their age, many factors go into that decision other than just their face, such as the way they dress or the way they talk. This can lead to inaccurate estimations of people's ages due to bias. In some applications, it's essential that these biases are eliminated. As people grow older, their facial structure changes, and we believe that these changes can be detected using artificial intelligence. As such, our goal through this project will be to eliminate human bias by using a machine learning model to estimate someone's age based on an image of their face. Our main motivation for this project comes from two real-life use cases. One is to collect data for marketing. Companies can use age data to tailor their ads or products to a certain age demographic. An example of this could be when customers walk into a store. An owner can collect data of what age people are that enter the store and stock up on products that those ages are more likely to buy. Another area this could be used is to enforce age restrictions at areas such as bars and clubs. Now I'll talk about how we created the model and how we made our decisions. Initially, we were thinking of working with the IMDb Wiki dataset as it has 500,000 pictures and the UTK Face dataset, which has 20,000 pictures. It might seem that the IMDb Wiki dataset is better due to having more images. However, there are many images that are incorrectly labeled, which would hinder the model's ability to learn. An example of this can be seen on the picture to the left, where a baby is labeled as 9 years old. UTK Face excels over IMDb Wiki in multiple other ways. To reduce bias towards a certain race or gender, it has been created with essentially equal number of samples of different races and genders. IMDb Wiki, on the other hand, predominantly has samples from races that are common in Hollywood. UTK Face also has photos that have been aligned to the person's face and have been cropped to the size 200 by 200, making them ideal to work with. Due to the benefits of UTK Face, we trained our model using this dataset. After dividing our images, we took a look at the age distribution and found that there was an excess of samples of people in the ages 20 to 30 and few samples of people above 40 or between 10 and 20, which can be seen on the graph to the left. We wanted to equalize the dataset in order to reduce overfitting to certain ages, so we introduced a cap to the number of samples an age can have. We then augmented our data. After doing this, you can see that our distribution is much more equal as number of samples of people above 40 is closer to the number of samples of people in their 20s. To add on to data augmentation, the transformations that we applied were adding noise, rotations, or gamma to approximately 50% of the images in the ages 40 and above or between 10 and 20. Now I'll hand it over to Kanjan to talk more about the model.
Our final model is a convolutional classifier. We use convolution as it works well with images, helping to maintain spatial context. So to begin with, we take our image, pass it into VGG11 for feature extraction. From there, it goes into a convolutional layer, followed by MaxPool, and into our fully connected layers, which at the end give the model outputs 104 different probabilities relating to the 104 different ages that exist in our dataset. From there, we use a softmax to get the final classification of our model. Also on the slide, you see the number of weights that we have per layer, along with some of the hyperparameters that we ended up tuning and choosing.
For quantitative results, we measured the performance of our models through 3 accuracy measurements: the exact age, within 5 years, and within 10 years. This was due to the fact that there is usually very little variation between each age, so a model's performance is usually better judged within an age range. As you can see from the test accuracies, the VGG11 model performed the best, which is why it was our chosen final model. Qualitatively, we can examine some of the predictions made by our model and if they are reasonable. On the left, we have 2 cases where the model predicted the age of the person well. Although it is not exact, it is within a few years. This makes sense as these pictures show people who look their age. If you were to give the same problem to a human, they would also likely guess well. On the right, we have examples of our model making bad predictions. But it is evident from the pictures that the people look young for their age, so this is expected. Many of the features that the model would have learned that represent older age groups, such as wrinkles, are not present in these images.
For the demonstration, we'll be testing on the following 5 images. These images are selected to showcase some of the strengths and weaknesses of our model when it comes to predicting ages. So right now you see these 5 images of individuals. We'll then show you the actual age and the predicted age from the model. But before that, maybe you can take the time to guess for yourself what you think the age of these 5 individuals are. So how well did you do? Our model didn't fare well. For the first picture of Angelina, the model was quite off. The model tends to underpredict ages when the face leans towards lighter skin tones and wrinkles are not very visible. A similar effect is seen in the last 2 images, where once again, the ages of these individuals was underpredicted. Then when you look at the second image, which is a picture of Hanif, a member on our group, his age was predicted to a fair degree of accuracy. Similarly with the third picture, which is a picture of my sister. The model here is able to predict them well as they kind of fall in the sweet spot of the model, which tends to be the late teens to the late 20s. This represents where most of our samples lie, and the model doesn't confuse it with the younger ages as it does with the other models, due to the younger kids having a fairer skin tone and less wrinkles. Additionally, for Keanu, since his age actually falls in at 55, our dataset does not have many samples. So once again, this is another reason why his age was severely off. Now, let's ask ourselves a real question. How old is our professor? Well, our model predicts him to be about 53. I don't really agree with that, but only he can say otherwise.
We learned some key points that we would definitely use if we were to do this project again. We would look more into parsing out samples that should not be in the dataset, such as these images that were found in the UTK face dataset. We also have fewer samples that we would like to work with, and in order to combat this, we can think of ways to clean the IMDb wiki dataset to have more data to train our model. Through this project, we also learned the importance of creating models that are suitable for the given hardware. Adding additional layers to our model often caused problems due to either RAM restrictions or it took too long due to the number of parameters being calculated. That is all from us. We'd like to thank you for listening, and if you have any questions, feel free to ask now.